Hi, today I would like to talk about integer linear programming is a category of optimization problems that seeks to find the best possible solution among linear constraints with integer decision variables. ILP was applied for Spencer Enterprise to identify the optimal combination of investment options that are subjected to the annual capital constraint to maximize the total net present value. The approach will be based on the formulation of a 0-1 ILP model, according to which each decision variable will be directly associated with the choice of specific investment. The constraints have a 3-year limit on the budget, the 3 projects for expanding the warehouse are mutually exclusive, and the test marketing must be followed by an advertising campaign. The problem is then solved and implemented in the Microsoft Excel server, which is widely used in business for making decisions. This assignment has well-illustrated modeling and optimization support clear, data-driven managerial decisions. It also highlights the effectiveness of ILP in solving real-world capital budgeting problems.
Okay, let me introduce integer linear programming. Integer linear programming is a mathematical optimization problem in which some or all of the variables are restricted to integers. Here is the development history. Integer linear programming origins from linear programming and the CPS method, with the branch and bound method appearing in 1950. Later, the cutting plan for integer programming was invented, and finally the branch and cut method in 1980. So, what are some real-world applications of integer linear programming? First is production planning. In agricultural production planning, integer linear programming can help to determine the yields of several crops. They can share results such as land, labor, capital, seeds, and fertilizer. Integer linear programming can also be applied to the planning field, where the basic goal of scheduling problems is to efficiently allocate resources, especially in transportation network. A typical application is bus or subway service and vehicle scheduling, which involve driver availability and vehicle allocation for specific routes to ensure operation according to a given timetable. Finally, is a telecommunication network. Another important task of this integer programming in telecommunication network is building line network while minimizing overall cost while maintaining network connectivity. To achieve this goal, two aspects need to optimize, which is the overall network layout and the capacity of each line. We also explore the advantage of integer linear programming. Integer programming plays a crucial role in fields such as logistics, finance, and manufacturing. It can handle decisions that cannot be broken down. For example, you can't have only half of driver or two of a car. It has a wide range of applications, including production planning, scheduling, transportation, and capital budgeting. This technique can effectively optimize data-driven systems that measure resource, time, and cost in this. We have three methods for solving integer linear programming problem. The first method is branch and bound. It is a commonly used programming paradigm. Branching refers to the process of generating sub-problems, while bounding refers to ignoring partial solution that cannot be better than the current optimal solution. For this, a lower bound and an upper bound need to be maintained. The second is the cutting plan method. This is an iterative optimization technique that solves complex problems, especially integer programming problems, by gradually narrowing the feasible region by adding cuts to linear inequalities. The cutting plan method can eliminate non-integer solution but retains valid integer solution until the optimal integer solution is found. Finally, there is the branch and cut method. It is a combination of the branch and bound method and the cutting plan method used to solve integer linear programming problems. These methods are implemented by solving a sequence of linear programming realization problems for integer programming problems.
Now I will continue with the particular application. Spanish entrepreneurs must choose among a series of new instrument alternatives, the potential instrument alternative, the net value of the further scheme of return, the capacitor replacement, and the available capacitor funds over the next 3 years are summarized as below the table that I have shown. For the alternative, there are 6. First is limited warehouse expansion, extends warehouse expansion, test market new product, advertise campaign, best research, purchase new equipment. For this, assume that there was only one of the warehouse expansion project can be in place. Suppose that if test market of the new product is carried out, the advertise campaign also must be conducted. Develop and solve an integer programming model for maximizing the net present value. Now I will continue with the integer linear programming. First of all, I will list out the variable. We will let xi equal to 1 if the alternative is chosen, and also xi equal to 0 for the otherwise. I mean 1, 2, 3, 4, 5, 6. For x1 is equal to limited warehouse expenditure, x2 is extend warehouse expenditure, x3 is test market new product, x4 is advertise campaign, x5 is basic research, x6 is equal to purchase new equipment. Now I will continue with the data analysis. With this report is using an integer programming model to help the station and premium to find out the best combination of insert project to maximizing total net present value. So for this situation, we will use the Microsoft Excel to solve this problem. But before we using the Microsoft Excel, we need to done three things that we should do. First of all is define the decision variable for the 6 project and also creating an objective function for the maximize total net present value, and also converting all the logical program straight into the mathematical constraint so that we can use this in the Excel so we can get the answer that we want. So now I will end my present for here, and my friend will continue with the other slide. Now I will continue with the data analysis. With this report is using an integer programming model to help the station and premium to find out the best combination of the insert project to maximizing total net present value. So for this situation, we will use the Microsoft Excel to solve this problem. But before we using the Microsoft Excel, we need to done three things that we should do. First of all is define the decision variable for the sixth project and also creating an objective function for the maximize total net present value and also converting all the logical program straight into the mathematical constraint so that we can use this in the Excel so we can get the answer that we want. So now I will end my present for here and my friend will continue with the other slide.
Before we solve this, we need to install Excel server. We go to the file, then we click option, then click the add-ins, then select Excel add-ins and click go, server add-in and OK. Now under the data tab, we can see the server here. After install Excel server, we need to set up our objective function, decision variable, constraint, and right-hand side value. So in this light green cell, we use equal, sum product, then select the coefficient, comma, select the variable, and then click enter. For the first constraint, we also use the same formula, equal, sum product, select the coefficient, comma, select the variable. Now I want to lock variable down by using F4 key, or we can add manually. Just start the $sign. For the next constraint, we just copy it down and make sure the formula is correct. And to solve this problem, you need to go to the data tab, then select the solver, then this window will appear. For the set objective, choose the light green cell, and this is a maximum problem. For the Byzantine variable cell, we choose the yellow cell. Subject to the constraints, we click the add, then click the left-hand side value for cell reference and choose the equality, and right-hand side value for the constraints, then click add. For the next constraint, we also use the same step, because all of these have the same inequality symbol. Click add. Then select the yellow cell, choose the binary, then click OK. So this is our subject to the constraints. Next, select the simplex RP for our solving method, and make sure this has set OK. Then we just click OK. We can know our result now. And to solve this problem, we need to go to the data tab, then select. After we solve our RP model using Excel server, we will get our result. x1, x2, and x5 is equal to 0, and x3, x4, and x6 equal to 1. Then our maximum net present value is 17500. The selected alternative are test market new product, advertising campaigns, and purchase new equipment.
In this study, the objective was to optimize new investment in Spencer Enterprise. The objective function was to maximize the total net present value, while subjecting to constraint on capital requirements for next 3 years. Only one of the warehouse expansions project can be implemented, and the advertising campaign must be conducted if test marketing of the new product is carried out. The ILP model consists of 6 decision variables, representing limited warehouse expansions, extensive warehouse expansions, test market new product, advertising campaign, basic switches, and purchase of new equipment, with 1 represented by selected and 0 represented by not selected. The solution was solved using Excel solver tools, following steps such as defining the objective functions, setting constraints, and ensuring non-negativity and integers variables conditions. The results show the test market new products, advertising campaign, and purchase of new products is selected to maximize the total net present value, which is 17,500.